Okay, question E. Let a and b be positive integers, careful, positive integers, such that a plus b is 20. What is the maximum value that a squared b can take? Good. Okay, so if you're someone who has done your A levels, yeah, and then you study in university and you see this question, you probably realize that this is a sort of a variation or a baby version of something called Lagrange multipliers in it. Yeah, those of you who do economics probably will see this sometime. Lagrange multiply. How do I spell this? There. Yeah. So it's like maximizing or minimizing something with a constraint. Yeah. So today the constraint is a plus b is 20. Right. So in this question, of course, you don't need to use techniques of Lagrange multiply, because there's only one constraint, right? But when you have multiple constraints or you have more variables, then things get more complex, because you get multivariable calculus in there, and then things are just annoying. You don't want to go there. Okay. So maximum value of a squared b. So of course we sub in a constraint first. Yeah. So a squared times 20 minus a. This is the function that we want to maximize. Yeah. Now we only have one variable, then life is easy from here, right? Because you only differentiate with respect to that variable, and then life goes. So this is 20a squared minus a cubed. So differentiate. This is my very bad notation. How do I indicate that I differentiate? Okay, diff or something. This becomes 0 equals 40a minus 3a squared. Yeah, 40a minus 3a squared. So, and we solve this. A times 40 minus 3a. Okay, so a is either 0 or a is 40 over 3. Okay, so when a is 0, I think it's clear that is the minimum, yeah? Because when a is 0, then the whole thing is 0. Yeah? So when a is 0 is the minimum. Okay, so we can get rid of this. This is the min. How about the max? So we could believe that a equals 40 over 3 should be the max, yeah? Because the question wouldn't make sense if it wasn't. If you checked it, then you can differentiate twice to check, yeah? But I'm not going to do that, so let's believe that is the max. But then we run into a slight issue, right? Because we need positive integers only. Yeah? So what's a sensible thing to do? Well, we might consider the integers which are close to this guy. Yeah? So 40 over 3, well, so what sort of integers does that help? So it should be 13, right? Or 14. Yeah, it should be 13 or 14. Yep, that guy is between 13 and 14, yeah, because it's between 39 and 42. Make sense? Okay, so let's see 13. What happens if I take 13? Well, so 13 plus 7 equals 20, right? So 13 squared times 7, okay, whatever that is. You would do that by hand, yeah, in the exam, which is not too hard. But I'm going to do it with a calculator and cheat, so because this is not very important. So this is 1183. And then you check 14 as well, yeah? 14 squared times 6 this time. I'm sure you all can do this quicker than my calculator, which is 1176. Okay, so 1183 is bigger, yeah? So then we take D as our answer. So if you have to be very rigorous, okay, technically if the max is close to 13 or close to 14, you can't really say that it is the max, because functions could behave very wildly within a small range, So let's say the function was this, okay, let's say the maximum was here, fine. But between 13 and 40 over 3, the function might be doing something dodgy. Yeah, so even if there's a max of 40 over 3, it doesn't necessarily mean that, if I only consider positive integers, then the nearest one must be a maximum. That's not necessarily true, yeah? It's just that MAT is nice to you. And they make that true all the time. Yeah, I realize you can't see the axes, but you could guess what I've written there. So it's 13 and 40 over 3. Yeah? So having max of 40 over 3 doesn't mean that 13, the closest integer, must also give you a max. That's not necessarily true. Yeah, but I think that's only for mathematicians, I guess. If you're doing the MAT for something else, maybe you don't care. But there you go. Okay, so that's question E.